Welcome to the tutorial room. Select a topic you would like to visit. Chapter 8, Introduction. Section 8.3, Like Terms. In this section, we'll teach you the definition of like terms and how to add and subtract terms in an algebraic expression. You'll also learn how to simplify algebraic expressions by clearing parentheses and combining like terms and constants. In algebraic expressions, like terms are terms that contain the same variables raised to the same power. Only the coefficients of like terms are different. Example 8.3.1. Below are 10 algebraic terms. Click on the button to group the like. These terms are like terms because they all contain the variables x squared y. Only their coefficients are different. These terms are like terms because they all contain the variables x, y squared. Only their coefficients are different. The remaining terms are unlike terms since none of them contain the same variables raised to the same power. This term is not an apple, x squared y, or an orange, x, y squared, because 2x squared y squared, both variables are raised to the power 2, 1/3 xy. Neither variable is raised to the power 2. Negative 5xy squared z. The term contains the variable z. Negative 7x squared yz. The term contains the variable z. Combining terms. Since adding or subtracting unlike terms is like mixing apples and oranges, only like terms can be combined. To combine like terms, add the coefficients and multiply the sum by the common variables. Example 8.3.2. Add the terms negative 8x squared y and 3x squared y. To combine these terms, use the distributive property to add first, then multiply. The distributive property in reverse tells us that when two terms have a common factor, like x squared y, we can add the numerical factors of the terms first, then multiply by the common factor. Example 8.3.3. Subtract negative 2xy squared from 4xy squared. To combine these terms, think of subtracting as adding the opposite. Then use the distributive property to add first, then multiply. When subtracting, it's a good idea to enclose the second term in parentheses to help keep track of the minus signs. To subtract these terms, we can either add the opposite of the second term or use the double negative rule since the negative of a negative is positive. Since both terms have the common factor xy squared, we can use the distributive property in reverse to add the numerical factors of the terms first, then multiply by the common factor. Simplifying algebraic expressions. When an algebraic expression contains parentheses, we have to clear the parentheses before we can combine the terms. To simplify an algebraic expression, 1. Clear the parentheses. Use the distributive property to multiply factors in front of parentheses by every term inside and remove the parentheses. If there is a positive sign in front of the parentheses, keep the sign of every term inside the parentheses the same and remove the parentheses. Remember, a positive sign is understood if there is no sign. If there is a negative sign in front of the parentheses, change the sign of every term inside the parentheses and remove the parentheses. If a term is raised to a power, use the rules of exponents to remove the parentheses. 2. Combine the like terms. Add the coefficients and multiply the sum by the common variables. 3. Combine the constants. Example 8.3.4. Simplify the expression 3z squared plus 6z times negative 4z plus 7y. To simplify this expression, start by clearing the parentheses, then add the like terms. To simplify this expression, we have to clear the parentheses by using the distributive property to multiply 6z by both terms inside the parentheses. Then we combine the like terms with the common variable z squared. Since the remaining two terms are unlike terms, this expression is simplified. Example 8.3.5. Simplify the expression 5m squared n cubed minus 6mn minus 4m squared n cubed plus 3 plus 6. To simplify this expression, start by clearing the parentheses, then add the like terms and the constants. Since there's a negative sign in front of the parentheses, we change the sign of every term inside and remove the parentheses. This is equivalent to multiplying every term inside by an understood coefficient of -1. Then we combine the like terms with the common variable m squared n cubed. We also combine the constants -3 and 6. Since the remaining three terms are unlike terms, this expression is simplified. Example 8.3.6. Simplify the expression. To simplify this expression, start by clearing the parentheses using the rules of exponents we learned in Chapter 7. To clear the parentheses, we use the power of a product rule to raise each factor inside to the exponents. Don't forget the coefficient 4 is one of the factors in this term. 4 squared is 16, and x cubed squared is x to the power 6, since the product rule tells us to multiply the exponents. Since both terms now have the common variable x to the 6th, we combine them for the final result. Now try some practices. Good job, you're right. Try again, that's not the right answer. That's not correct. Try again. Try again, that's not the right answer. Excellent job. Good job, you're right.